Hello everyone, in this video we will learn all about parallelograms. To begin with, let's have this quadrilaterals family tree. Now a quadrilateral is any four-sided polygon. The sides are considered as segments while the endpoints here are considered as vertices. Now quadrilaterals, it is grouped into three. The first group, it is a set of quadrilaterals in which it has two pairs of parallel lines, in which it is considered as a parallelogram. Take note, the markings here indicates that this side and this side, they are parallel. The double markings at the bottom and at the top indicates that these two sides here are also parallel. Now parallelograms, it has three kinds. It could be a rectangle, it could be a rhombus, or it could be a square. Now another group of quadrilaterals are quadrilaterals with one pair of parallel lines, and it is considered as a trapezoid. Now take note, this markings here indicates that the side up and down are parallel. Trapezoid, it has two kinds. It could be an isosceles trapezoid or it could be a right trapezoid. Now, the last group is a group of quadrilaterals in which it has no parallel sides and it is considered as a kite. Now, looking at this family tree of quadrilaterals, we can conclude that all squares are considered as quadrilaterals. All parallelograms are considered as quadrilaterals, but not all parallelograms are considered as a square. Not all rectangles are square, but all squares are considered as rectangle. Take note of that. Now, we will focus more on parallelograms. Now, a parallelogram, it has different properties. The first property is that any two sides are congruent. So with this, AD is congruent to BC and AB is also congruent to CD. By the way, when you name a parallelogram, you should follow a counterclockwise or it could be a clockwise direction. So considering this parallelogram, we can name this as parallelogram ABCD, or this could be a parallelogram ADCB. So take note of that. Now another property is that two opposite angles are congruent. So with this, angle A is congruent to angle C and angle B is also congruent to angle D. Next property, consecutive angles are supplementary angles. So with this, angle A added by the measure of angle B should total 180 degrees. Or it could be angle B added by the measure of angle C should total 180 degrees. Okay, next property. A diagonal of a parallelogram forms two congruent triangles. So, for example, BD here is a diagonal. So, with this, triangle ADB is congruent to triangle CBD. Or if we will have diagonal AC, triangle ABC is congruent to triangle ADC. So take note of that. And the fifth property is diagonals of a parallelogram bisect each other. So take note with this, AC and BD intersect at point E. So with this, we can say that AE is equal to CE, or it could be DE is equal to BE. So take note of that. Now, given this, what condition guarantees that the figure is a parallelogram? Now, given this, you have there AB is 6, CD is 6, AD is 7, and BC is 7. Now, this one is a parallelogram because the opposite sides are congruent. Okay, another. Now, given this angle is 115 degrees, The opposite is also 115. This angle is 65 degrees and its opposite is also 65. Now this one is a parallelogram because opposite angles are congruent. Okay, another. Given this, based on the markings, we can say that this one is a parallelogram. It's because the diagonals bisect each other. Okay, another. Now, given this is also a parallelogram, and based on the markings, we can say that a diagonal forms two congruent triangles. And last, this one here is 65 degrees and this one here is 115 degrees. Now this one is a parallelogram. It's because consecutive angles are supplementary angles. 65 plus 115, that will sum up 180 degrees. Okay, now given this is quadrilateral MATH, and this is considered as a parallelogram. Okay, now given this, segment MA is congruent to segment TH. So MA and TH, they are opposite sides. Now triangle MAH is congruent to triangle THA. And segment MS is congruent to segment TS. Triangle THM, that's the right triangle, is congruent to triangle MAT. Another, angle ATH, which is this angle, is congruent to triangle or angle HMA. Now, given this, if the measure of angle MHT is 100 degrees, if this is 100, then the measure of angle MAT, which is the opposite, is also 100 degrees. Another, if the measure of angle AMH, which is this angle, is 100 degrees, then the measure of angle MHT, which is a consecutive angle of the given, is 80 degrees. Another, if segment M to H is 7, therefore A to T is also 7. If A to S is 3 units, then A to H, that would become 6. Then last, if M to T is 9, therefore SM is considered as 4.5. Okay, another. Now, given this, quadrilateral HERO is also a parallelogram. Now, given this, if HE is 2x and OR is x plus 5, what is the length of HE? So to do this, take note. HE is equal to OR. So with that, we can equate 2x to x plus 5. So transfer x to the other side. So we will end up with x is equal to 5. To find HE, that would be 2 times 5. So therefore, it is 10. Okay, another. Now, given this, if the measure of angle OHE is 3 times the measure of angle HER, find the measure of angle OHE and angle HER. So take note here, OHE plus HER, they are considered as consecutive angles. So when you total them, it should be 180 degrees. So since the measure of OHE is 3 times HER, we can have the angle HER as x, and we can have OHE as 3x. So with that, adding up, it should be 180 degrees. So dividing both sides by 4, we will end up with 45 degrees. Now to find the measure of angle HER is 45, and to find the measure of OHE is 3 times of 45, in which it is 135 degrees. 45 plus 135, that will total 180 degrees. Okay, another. If the measure of angle HER is 5y minus 25, ROH is 2y plus 40. What's the measure of angle ROH? So take note, HER and ROH, they are considered as opposite angles. So therefore, they are congruent. So with this, we can substitute, transfer 2y to the other side. So this would become 3y, and 40 plus 25 is 75. Dividing both sides by 3, so the value for y is 25 degrees. And to find the measure of angle ROH, so that would be twice of 25 plus 40, so that would become 90 degrees. Okay, next. Okay, so let's have this geometric proofs. Now, a lot of students find proving in geometry challenging. So with that, before we will start, I would like to share with you some tips on how are you going to do it. Number 1, know your postulates, theorems, definitions, and properties. So take note, I'm not only referring to the different properties that we have this time, but it's really postulates, theorems, definitions, and properties of geometry. So from the very simple ones to the recent or to the complicated ones, it would be good that you have a list of this that you can scan through from time to time. So take note of that. Another one is label your drawing or label the drawing, because this will give you clue as to what have you proven so far. So somehow it will give you direction as to where you are going to. Next, know where you are going to. So with this, always look at what is required. What is required in the given, so that it will give you idea how are you going to get there, and it will give you direction how or what will you do in order to get there. And last is the given is always given for a reason. So somehow the given will give you clue how to get to your destination or to what is required in the given. So take note of that. Again, know your postulates, you label the drawing, you know where you're going, and take note, the given is always given for a reason. So let's start. So we have here a parallelogram HOME. So prove that segments SO and ME are congruent. Segments OM and HE are also congruent. So one thing that makes proving challenging is that your way of proving might be different with the way how your classmate is doing it. So with that, I'm giving here already a table. So all you have to do is fill it up. But take note, you cannot fill it up if you don't know your proofs, you don't know your theorems, your postulates, your definitions, and your properties. So take note of that. So in here, reason 1 is already given. So since we only have one given, so that would be parallelogram HOME. So another thing, your previous statement most of the time is also connected to the second statement. So take note here, in reason number 2, we have here a definition of a parallelogram. So with that, we can say that HE is parallel to MO and HO is also parallel to EM. So take note, you have to label your drawing. So with that, we have to put our markings in here. Next, statement 3 states that you have to draw EO. So drawing EO, we get here. So with that, EO is a diagonal. Next, your clue here for reason 4 is alternate interior angles are congruent. So take note, these are properties that you have learned when you were in grade 8. So with that, we have here angle HEO is congruent to this angle because they are alternate interior angles, as much as angle MEO is also congruent to angle HOE by alternate interior angle. So take note of that. Then we have here a reflexive property. So your clue here is that you have here EO is congruent to EO. It's because EO is a side common to the two triangles, in which that's where we are heading to prove that these two triangles are congruent. So with that, mark it. So with this, triangle HOE is congruent to triangle MEO by ASA. So we have here angle, you have a side, and you have an angle. So for the second triangle, you have here an angle, you have a side, and you have an angle. So take note, in ASA triangle congruence states that if an angle, a side, and an angle of one triangle is congruent to an angle, a side, and an angle of another triangle, the two triangles are congruent. So take note here for statement 7. So HO then is congruent to ME, and OM is congruent to HE by CPCTC, or corresponding parts of congruent triangles are congruent. Take note of that. Okay, another. We have here parallelogram just. So prove that angle JUS is congruent to angle STJ, and angle UJT is congruent to angle TSU. So take note here, we have here a given. So we only have one given, so that's parallelogram just. So second statement, you have to draw UT and JS. Take note, they are diagonals of a parallelogram. Next, your clue for number 3 is that opposite sides are congruent. So with that, you have here JU congruent to ST, and JT is congruent to US. And next, you have here a reflexive property. So in which we have here UT is congruent to UT. That would refer to common to the two triangles up and down, or yes, and you have here JS is congruent to JS, referring to this triangle and this lower triangle. So with that, we can say that these triangles are congruent by SSS. So you have here a side, and you have a side. So if the three sides of one triangle congruent to the three sides of another triangle, it would follow the two triangles are congruent. So with that, these angles here, angle U congruent to T, and angle J congruent to angle S by CPCTC. Corresponding parts of congruent triangles are congruent. Okay, next. Okay, we have here parallelogram live. So prove that IV, VE, angles E and L and I are supplementary angles. So take note, reason 1 is given, so that's parallelogram live. So take note, your clue here is LI is parallel to VE. LI is parallel to VE. So that's definition of parallelograms. No, opposite sides are parallel. So with that, we can say that if this two here, it's parallel. So with this, I and V are supplementary angles based on IS. So meaning interior angles on the same side of the transversal are supplementary angles. So that's why I and V are supplementary angles. So with this, I, E are congruent angles, and V and L are also congruent angles. Why? Because opposite angles of a parallelograms are congruent. So take note, I and V, they are supplement. L and E, they're also supplementary angles. So it would follow V and L are congruent, and I and E are also congruent. So with this, we can say that this angle pairs here are supplementary angles, because an angle that is supplement to one of two congruent angles are supplement also to the others. So take note of that. Okay, next. We have here parallelogram QR. So with diagonals CR and UE. So prove that CR and UE bisect each other. So take note, we have one given. So that would be this one. So take note, CU and ER are congruent because opposite sides of parallelograms are congruent. And mark it. So CE is parallel to UR. So still, that's definition of parallelogram. Opposite sides are parallel. Another. CUE and REU are congruent because of alternate interior angles. They're alternate interior angles, so therefore they're congruent. The same thing with CHU is congruent with angle RHE because they are vertical angles. And vertical angles are always congruent. So with this, we have proven that triangle CHU is congruent to triangle RHE because we have here an angle, we have another angle, and we have a side. So meaning, if you're given two angles and a side, and if it's congruent to the two angles and an opposite side of another triangle, it would follow that the two triangles are congruent. So with this, these corresponding parts here, they are CH is congruent to RH and EH is congruent to UH because of CPCTC. Our corresponding parts of congruent triangles are congruent. So with that, we can say that CR and UE bisect each other because that's a definition of segment bisector. So if these two are congruent and these two here are also congruent, so therefore these two here are bisecting each other. So take note of that. Okay, for the last property of a parallelogram, we have here parallelogram axes. So with diagonals AI, so prove that triangles AXI and ISA are congruent. So take note, we have a given. So parallelogram axis with diagonal AI. So take note your clue here. AX is parallel to IS. So take note that's opposite sides of parallelogram are congruent. So we have here angle XAI. So this angle and angle SIA are congruent because they are alternate interior angles. So marking them, we have this. And we have here a reflexive property. So a side which common to the two triangles here. We have here AI and AI. So another here is angle XIA is congruent to angle SAI because they are also alternate interior angles. So with this, we have proven that these two triangles here, the bottom and the top, are congruent because of ASA triangle congruence. Because you have here an angle, you have an included side, and you have an angle. So take note of that. Okay, so let's have the special parallelograms. Now take note, there are three special parallelograms. We have here a rectangle, we have here a rhombus, and we have here a square. So take note, a square is a rectangle and a rhombus combined. So whatever are the properties of a rectangle and properties of a rhombus, it is also part of a square. So take note of that. Okay, so let's have this one by one. So take note, whatever are the properties of a parallelogram, it is applied in this three. So for a rectangle, its first property is that all angles are right. So all angles here measures 90 degrees. And the other one, the diagonals here are congruent with each other. So take note of that. So given here, if AC here is 8, so therefore BE would be 4 cm. If AE is 2 inches, so therefore BD is 4 inches. Okay, another. Now, if AD is 5 and AB here is 12 meters, so to find BD is we have to make use of the Pythagorean theorem that states that if AD squared plus AB squared is equal to the hypotenuse BD squared. So with this, we'll substitute. So simplifying further, so BD is 169. Get the square to both sides. So the length for BD here would be 13 meters. Okay, another. AC here is 10 meters. Our BC here is 6 meters. So find AB. So take note here, it's still forming a right triangle. So with that, that would be BC squared plus AB squared equals AC squared. So substituting, we will get this. So transferring 6 squared to the other side. So that would become 64. Getting the square root. So our AB here is 8 meters. So take note, we have to make use of the Pythagorean theorem. Okay, another. Now, for rhombus. All sides are equal. It is a parallelogram with equal sides. That's a rhombus. Okay, another. Diagonals are perpendicular. So when you see perpendicular, at this point, it is forming a 90-degree angle. And each diagonal bisects two of its angles. So this angle here, it is bisected. So take note, this is only applied for rhombus. The bisecting of angles, this is not applied in a rectangle. So given this figure, we have here a rhombus MNOP. So if MO is 10 cm, then MR, that would be 5 cm. If P to R is 3 inches, then P to N, that would be 6 inches. What is the measure of angle MRN? So you're referring to this angle, that is 90 degrees. Now, if the measure of angle MPO, or this angle here, is 80 degrees, what then is the measure of angle MNP? So take note, it's only half, so therefore that would be 40 degrees. Now, if P to O is equivalent to 4 meters, what then is the perimeter of this rhombus? So that would be 16 meters because all sides here are equal. Okay, another. Now, if M to O is 6 cm, P to N is 8 cm, so how long would be MN? So take note here, we can make use of a right triangle here. So that would be MR squared plus RN squared is equal to MN squared. So substituting, if MO is 6, so MR would be 3. And if P to N is 8, so therefore R to N is 4. So with this, simplifying, we'll get 9 plus 16, or that would be 25, getting the square root to both sides. So therefore, length of M to N is 5 cm. So take note of that. That is for rhombus. Okay. Now, let's have for a square. So what are properties of a square? So take note, a square is a rectangle and a rhombus combined. So with this, all sides are equal and all angles are right. That is a square. Next, diagonals are congruent and at the same time perpendicular. Take note, in a rectangle, diagonals are congruent. For a rhombus, diagonals are perpendicular. For a square, diagonals are congruent and perpendicular at the same time. So take note of that. And each diagonal bisects two of its angles. So take note, if all angles here are 90 degrees, so it would follow that half of this would be 45 degrees. Now, given this figure, it's a square. If A to E is 10 cm, so that would make B to D as 20 cm. Now, what is the measure of angle ACB? So it's referring to this angle here, that is 45 degrees. What about the measure of angle AEB? So this angle here, that would be 90 degrees. Okay, another. Now, if A to B is 8, therefore, how long would be AC? So with this, we can have AB squared plus BC squared is equal to AC squared. So take note, our AB here is 8 and our BC is also 8. So simplifying further, that would be 64 plus 64, that's 128. Getting the square root to both sides. So the value for AC here would be 8 square root of 2. So take note of that. Okay, another. Now, if A to B is 12 meters, so how long would be A to E? So with this, we can form AE squared plus EB squared is equal to AB squared. So take note here, AE and EB are congruent. So we can have it as x squared, and x squared equals AB squared. Or that would be 2x squared is equal to 12 squared. So that would become 144. dividing both sides by 2, so x squared would become 72. So getting the square root of both sides, so x here would be 6 square root of 2. So with that, the length for AE here would be 6 square root of 2. So take note of that. Okay, so let's use the different properties of special parallelograms in proving. So given here, ABCD is a square and B is a midpoint of AE. So prove that CBE is an isosceles triangle. So given this, so we have here our given. So our reason is given. Statement 2 here would be, take note of this clue. B is the midpoint of AE. So with that, AB is congruent to BE. So that's definition of midpoint. So marking it, we'll get this one. So next is definition of a square in which AB is equal to CB. So marking it, AB is congruent to CB. So with this, we can prove that BE is congruent to CB. That is by transitive property. AB is equal to BE. AB is equal to CB, so it would follow that BE is also equal to CB. That's by transitive property. So with that, indeed, triangle CBE is an isosceles triangle based on a definition of isosceles triangle in which two of its sides are congruent. Okay, another. Okay, given this, WXYZ is a rhombus with diagonals WY and XZ. Prove that triangle ZYT is congruent to triangle XYT. This triangle and this triangle are congruent. So, again, always begin with a given. So, we have here a given. So, that's it. So, your clue for the second statement would be this one. So, ZY is congruent to YX. That is because sides of a rhombus are congruent, or that's definition of a rhombus. So another here is ZT is congruent to TX because diagonals of a rhombus bisect each other. So marking it, we will get this one. Okay, now your third here clue or the next step would be YT is congruent to YT. It's because this YT is a side common to the two triangles. So that is by reflexive property. So with that, indeed, the two triangles are congruent because of side, side, and side. So that is SSS, triangle congruence. Okay, so let's have this area of quadrilateral. So given this different quadrilateral, so let's review its different formula for area. For parallelogram, that's base times height. For rhombus, that's diagonal 1 times diagonal 2 divided by 2. For rectangle, that's length times width. For a square, it's simply s squared. For a trapezoid, that would be base 1 plus base 2 multiplied with the height divided by 2. Then for a kite, that would be diagonal 1 times diagonal 2 divided by 2. So let's have this. So we have here a parallelogram. So your base is 8 and your height is 4. So our area here is 32 centimeters squared. Okay, next we have here a rhombus. So diagonal 1 times diagonal 2 divided by 2. So that's 8 times 10 divided by 2. So that would be 40 square units. Okay, another. We have here a trapezoid. So substituting our base here 5 and 7. Then our height is 3. So 7 plus 5, that would be 12. Times 3 is 36 divided by 2. So that would be 18 centimeters squared. And we have here a kite. So diagonal 1, diagonal 2 over 2. So diagonal 1, so if this 3, so double. So that would be 6 times 10 divided by 2. So that would be 30 centimeters squared. So let's have this sample problem here. Finding the area of the shaded part. So take note here. First one. So area of a rectangle, so that would be 10 times 6, so that would be 60 meters squared. And area of the triangle, that is 2 times 6 divided by 2, so that would be 6 meters squared. So therefore, the area of the shaded portion here would be 60 minus 6, or that would be 54 meter squared. Okay, another. Now for this figure, we have here a big square, so in which the side is 8, so square area to that would be 64 meters squared. And the area of the smaller square would be 9 meters squared. So area of the shaded part would be 64 minus 9, or that is 55 meter squared. Okay, now for this one, we have here the area of a rhombus. So this is 16. And how is 12 obtained? So take note, this is 10 and this is 8. So by Pythagorean theorem, that's 100 minus 64, or 36. Square to that, this is 6 and this is also 6, so that would be 12. So area is 96 meters squared. So area of the shaded part is 48. Why 48? Because it is half of the rhombus. So take note of that. Okay. Okay, let's have this sample word problem. Area of a square whose one side measures 7 cm. So to do that, that's A equals S squared. So 7 squared, so that would be 49 meters squared. Okay, another. Area of an equilateral triangle whose one side measures 8 centimeters. So take note, equilateral triangle, so meaning all sides that measures 8 cm. So it would follow that all angles here are also 60 degrees. Now, take note, we don't know the height yet. So this is the height. So getting half of this, so this would become 4 cm, and this is 4 cm. If previously this was 60, so getting half, so this is 30 degrees. So take note, this would become a 30, 60, and 90 degree angle. So this is our hypotenuse 8. Our base here is 4. So by Pythagorean theorem, so this height here would be 4 square root of 3. So to get its area, so base and height divided by 2. So our base here, it's basically the entire base, which is 8. And our height is 4 square root of 3 divided by 2. So the area of this triangle is 16 square root of 3 centimeter squared. Okay, so that would be all about parallelogram.